whoa. That was much more powerful. We've realized that this tank might be too small to get a reliable result, but when we punched it to the max very fast, we almost got 50 kilograms. And after taking into account the geometry of the rig, it's actually just 50. So let's double it, for a total of 100 kilograms, which I hope is sufficiently larger than the 79 kilo. That is the first component of our new jetpack. However, as you probably noticed already, this design quickly comes out to be extremely dangerous. By strapping these motors to our back, we are becoming a part of the vehicle. A vehicle that can easily sink, since now we got a 100 kilogram person potentially pinning us down underwater. That's why we decided to make this jetpack able to transform into another vehicle, an underwater scooter. We will test it in both configurations and see which one is better, although I've got a strong suspicion for which one is faster. But when it comes to our safety, the scooter has a big benefit. You can simply dismount by letting go of your hands. Okay, but still, how do we plan on steering and regulating acceleration precisely enough in such a way that we don't crash into the wall? Here's our solution. This is our custom throttle mechanism. It's mounted on the handle and you can push it with your finger just like a non-underwater electric scooter. Here's a spring which makes it return after you let go. Now there are two small magnets on the moving part, and in between them there's a small sensor that measures how magnetic field changes. So here is 0 speed and here's full throttle. We needed to cover these sensors in epoxy so that they could be submerged underwater. Hopefully it should work the same underwater as in air. But in order to have even more control, we've added a waterproof button which mounts in between the two handles. Clicking it, it cycles through 4 speed modes, from the slowest to the highest. It was kinda hard to find a good waterproof button online, so I hope this one won't cause any problems. Good, that makes the vehicle already pretty controllable, but what if the plastic throttle lever is just simply stuck, and it's forced to accelerate forever? Well, that's why it's always a good idea to add this button. You can only accelerate after pushing this down, so if you let go, it's no longer pressed and the scooter shouldn't accelerate, even if the throttle is engaged. Very fittingly, it's called a dead man's switch. Good, now we have double protection. However, what if the software just fails and the button doesn't work? Well, for that we added a magnetic switch which mounts in front of the handles. You then attach a magnet right on top of it, which turns on the switch, and so the vehicle. You tie the magnet to your arm with a string, and now, once you dismount, the magnet is also pulled off, and the entire vehicle turns off. This is called a kill cord. And finally, in case all of the systems work, but you still manage to put your hands in the propeller, we added these motor guards with a grill on the outlet so that you cannot insert your hands. You could if you're a baby. That should be enough. We shouldn't die now. But even after all of this, we are still omitting one big thing. How are we supposed to build the main structure, and how to make it both a jetpack and a scooter? Yeah, we had a lot of ideas.
We're not sure which way is the best way. Like swappable attachments on the side. So this is what we call the jetpack bro. Guy standing on a drone thing. Maybe this will allow you to walk on water. So that's good. And then...
But after a lot of going in circles, we had a bit of a eureka moment, thinking of a very simple structure. Now we have to do a lot of 3D printing, specifically in orange. Thank you Bamboo Lab for providing us with all of these printers and sponsoring the video. You might wonder, since it's an underwater jetpack, are these 3D prints waterproof? They are not, but it's only the pipe in the middle that will hold air on the inside. This huge pipe is for the electronics and the batteries. Everything around the pipe can be filled with water, no problem. For some of the bigger prints, we're using the biggest Bamboo Lab printer, the H2D. And it has a lot of cool functions, but what's interesting is that even the much more affordable P2S has the same print quality. So these parts are held together using these 6 metal rods. Then the carbonate sheet on the top and the bottom adds strength, while still making the inside visible. And we'll be able to screw in a backpack mount to this sheet here, for when it's a jetpack. Last thing about Bamboo Lab, P2S is an upgraded version of P1S, a fully enclosed Core XY 3D printer that allows you to print with advanced materials like ABS or polycarbonate. And so check out their link in the description, since right now they have Black Friday sales. After 3D printing this structure, it honestly appears quite bulky. That's why we also designed big domes for the front and the back. They make it a lot more hydrodynamic. The thing is, it's not only the hydrodynamics of the vehicle that are important. It's the entire human and vehicle system which we need to optimize. That's why we also bought a triathlon wetsuit, which supposedly is a bit more hydrodynamic than a normal one, because of the smooth surface. In any case, we know that this scooter and jetpack can probably be much more hydrodynamic. But a simpler design will be much better to start with, and we do believe in our very large thrust. We'll see if that bites us back. When it comes to the thrust and the power these motors require, it all comes from a big battery pack. And this one can deliver 9 times more power than the Reliant batteries we normally use. We had to design a separate custom PCB in order to connect these batteries together, and all of these MOSFETs will turn the vehicle on when you plug in the turn-on key. Because of the power, it heats up so much that we decided to add this large heatsink. Now it just needs a mounting plate, because all of the electronics fit onto 3 rods. We also have a battery management system board, and an ESP32, which connects to all of the buttons and runs a program, mounted on a perf board for convenience. After 4 days of soldering and solving more small problems than we'd like to admit, and then some cable management, we slide it into the pipe. Some cables have to come outside via these penetrators in the end cap, and in front of them these are very powerful electronic speed controllers. They directly control the motors, and they will heat up so much that we need to put them outside in the water for water cooling. These are the last couple of parts we need to attach and screw in, like the button module, the handles with the throttle, and in order to attach the human as a jetpack, here's a scuba diving harness we found. It has very convenient hooks in the back. Quick test? Seems to work, and it mounts just like that on the bottom, but let's take it off for now. The last part is the dome. It's kinda hard. It is done. Let's call it... I actually don't know what to call it, because for the first time on our channel, it's not a submarine, so we cannot say CPS. So I ask you, write your suggestions in the comments. Meanwhile, let's do another thrust test.
No. Oh shit, I'm sorry.
Immediately we saw an issue. For some reason it worked fine when not submerged, but when we